Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem subsets. So we are given an integer array nums, and all we need to do is return every single possible subset that we could create from the input nums. And we do not want to include any duplicate subsets. So what is a subset? Well, let's say we have 1, 2, 3 as our input. One subset, of course, would be 1, right, by itself. Another subset would be 2 by itself. We could do 1, 2 together. Now, what happens if we do 2, 1, right? We just swap the order. Does that count as a different subset, or is that the same as this subset? Well, they're the exact same. We don't care about the order. This is not a permutation. This is a subset. So it's not a permutation, it's a subset. So we do not want to include duplicates, and this counts as a duplicate. We're not going to include it. And 3 is another subset. 1, 3, 2, 3, 1, 2, 3. The original input is technically also a subset. And we also don't want to forget the empty subset. So no matter what we're given, an empty subset is technically a subset of this as well. So if we want to create all the subsets from this input, we have a choice for every single element. So for this 1, we have a choice of include the 1 in our subset or not include the 1, so we get an empty subset, right? So we have that choice, and we have that choice for every single input element. So in total, we have 2 choices here, 2 choices here, and 2 choices here. So this is going to be 8, or in other words, 2 to the power of n, where n is the size of our input, right? So this is the number of subsets, and we don't want the number of subsets, we actually want the subsets themselves. So how long could a subset be, right? Well, we could have a subset 1, 2, 3, right, the size of our input. We could also have subsets that are smaller, right, like 1, 2, maybe 2, 3. So as you can tell, this is not going to be an efficient problem to solve. We have this many subsets, and each subset could be up to length n. So the worst case time complexity of this problem is going to be n times 2 to the n, regardless of how efficient we make it. Because given the constraints of this problem, we don't want the number of subsets, we want the subsets themselves. We have to make it inefficient. So with this in mind, we can just jump straight into backtracking, which is the brute force way of solving this problem, but it's also pretty much the most efficient way. So like I said, for each of these elements, we have a choice. So I'm going to draw the decision tree. So first, we can choose to add 1 or not add 1, and that will give us 2 subsets, 1 subset with just 1 and 1 empty subset. So along this path, we can decide now, do we want to add 2 or not add 2?